pathway here into the alveolar sac, where the CO2 is then exhaled and goes out the body. Oxygen then comes in, or oxygen and CO2 are there at the same time. Oxygen here then diffuses across this diffusion gap diffuses into the blood and into the red blood cells, for them to carry away to the working muscles and cells of the body and organs. There are approximately 300 million alveoli in the lungs. This increases surface area and creates a large surface area. Also, the shape of the alveoli create a large surface, increases the surface area even more. There's a large network of capillaries around each alveolar sac. This increases the amount of oxygen and CO2 that can enter the body and the blood vessels and working muscles and exit the body as well. There's also a very short diffusion pathway here. This allows optimum gaseous exchange to occur. Here we've got lung volumes, and number one is the tidal volume, and tidal volume is the amount of air that we forcibly breathe. Tidal volume is the amount of air that we breathe in normally in a single breath. Number two is the vital capacity, and the vital capacity is the amount of air we forcibly breathe out after each maximum inhalation. And number three is the residual volume, and what the residual volume is the amount of air left in our lungs after each exhalation. And this last bit of air left in our lungs is important because what it allows the lungs to do is allows them to maintain their shape and stop it from collapsing in on itself. And then you've got control of breathing, which is the last one. Your neurocontrol, chemical control. For neurocontrol, neurocenters are located in the medulla oblongata and the pons. The neurocenters there. In the medulla, self-exciting inspiratory center, or pacemaker, is there. And then there is a expiratory center. And what this does is the expiratory center inhibits the pacemaker and gets it to, and this sets the rhythmic tone of our breathing. And then what the pons does is it smooths out our breathing rhythm. Lastly, we've got chemical control, and this is related to the pH in our blood and all of that. So if there's a decrease in the pH in our blood, then there is then chemoreceptors detect this, and they know that there's an increase in the CO2 levels in the blood. So what it does is the chemoreceptor sends signals to the medulla, which sends signals to increase the breathing rate, and the medulla then sends signals down the phrenic nerve, telling us to breathe, to increase our breathing rate, to increase oxygen uptake into our body, as well as depth. Also, the brain medulla sends signals down the intercostal nerve, and what this does is it gets the external and intercostal muscles to expand and contract faster, so more oxygen can enter the body and more CO2 can leave the body faster.